Organizations are embracing public cloud to accelerate their operational velocity, and this has revolutionized the way they deploy and manage their applications. But they are also faced with the task of ensuring that operations are secure, applications are available, and cost is optimized in a complex and dynamic environment. And especially with the adoption of multiple clouds, the ability to govern environments at scale from a single point of control is essential. Hello, everyone, and thank you for joining us for this session. I'm Jyoti Sharma, and I'm a product marketing manager for a multi-cloud governance solution. And joining me today is my colleague, Michael Poor, from technical marketing at the Cloud Management Business Unit at VMware. Today, we will talk about the public cloud governance challenges and how you can ensure continuous implementation of cloud standards by combining preventative and detective techniques, and then also a quick introduction to VMware's multi-cloud governance and policy management service. In a VMware study with Cloud Security Alliance, it was found that 1 in 6 organizations had a security breach due to a cloud misconfiguration. Now, cloud misconfigurations are a top concern for organizations utilizing public cloud, since such configuration mistakes can not only lead to security breaches, but also wreak havoc on business operations. In another research, it was found that most organizations are still attempting to solve issues associated with public cloud governance, compliance, and security, and only 1/3 of respondents have solved these issues. Even fewer have solved cost and performance optimization issues. So we can see that governance is a perennial challenge and that considerable effort is needed to put controls early in the process and use the approaches that ensure that governance practices are implemented and guardrails are built so that infrastructure and applications are secure and meet enterprise standards, the applications are available, and the cloud budgets and costs are optimized. Now let us see how our cloud policy is implemented by many organizations. Public cloud governance has been evolving over the years with engineering teams building apps faster, and now FinOps teams, architects, and security teams getting more involved in governing the cloud. As organizations are centralizing implementation of governance standards, cloud operations team plays a key role while provisioning accounts to ensure that governance practices are implemented. On one hand, they need to fulfill the demand for compliant accounts by provisioning these accounts for multiple app teams, while on the other hand, they need to implement the policies set by security, architecture, and FinOps teams and ensure that resources are compliant at all times. For example, security teams require that IAM password policy is configured, or AWS config is enabled in all available regions, or FinOps may require to limit the size of VMs as per set budgets. But they are not just required to configure these policies, they also need to maintain compliance from the time when they create the landing zone and hand off the account to the user. And as those users are building the applications, they need a mechanism to keep up with these changes in configurations and track compliance. So eventually, the cloud operations teams are responsible for implementing these policies and maintaining compliance across environments without compromising developer agility. Now let us see what challenges do they face that prevents them from uniformly implementing cloud standards. Cloud operations teams rely on manual processes or scripts to apply policies to accounts, which leads to inconsistent implementation of policies across cloud environments and slows down provisioning of accounts for multiple teams. Most organizations are using homegrown tools or native services, which are not sufficient. These multiple compliance tools also create data silos, and the stakeholders need to refer to multiple dashboards to track compliance to standards that need to be implemented. So as a result, there's a delay in detection of configuration drift, and often policy violations go undetected and unmitigated. Another one is lack of knowledge of all the best practices for cloud services across providers. Even after the environment is set up for day zero, the app teams start deploying more services, and they do not have the expertise on best practices, which further increases non-compliant resources in the environments and raises the risk. Now, as you add more teams, accounts, and providers, the problem of inconsistently managed and implemented policies becomes even bigger. And the process of provisioning, detecting compliance issues, and remediation becomes slower. This means, again, increasing compliance risk. Now, to overcome these hurdles, there's a solution that combines the preventative and detective approach, which helps to create accounts with predefined policies in landing zones. And after handing over these accounts to the user, enabling you to track configuration changes and remediating drift automatically. VMware Aria Guardrails provides landing zones to create accounts with predefined policy configurations using IAC templates. These templates enable to stamp these policy configurations across accounts consistently without requiring manual effort or scripts. The service also provides a unified visibility into the drift and violations across different policy engines in a multi-cloud environment for the central governance and app teams. The service leverages event-driven detection of drift and automated remediation to ensure compliance post-deployment. The solution also provides many out-of-the-box policies across costs, security, and operations, which are very easy to use. Access to policy templates, as well as thousands of inbuilt policies that detect violations for resources across AWS, Azure, GCP, and Kubernetes, makes it easy to benchmark compliance against industry standards and best practices. It is also possible to create custom policies that meet the organization's unique needs. In this section, we will discuss the preventative and detective techniques. So let us start with the proactive approach of creating cloud accounts with predefined policies. The first step is to define policy configurations for your accounts based on the scope for the accounts. In case of AWS, this could include some mandatory SCP policies or operational policies or security policies. Then while creating the accounts, you also need to define what the account hierarchy will look like and where is the account getting created. Now, these accounts are often scoped based on teams that requested the account or based on your resource isolation or security isolation, and then policies are configured into the new account. VMware Aria Guardrails combines these three steps into a simple workflow where you can define the desired state in IAC templates, create accounts in a landing zone, and then auto-apply the desired state for all the accounts created. Using templates ensures that the policies are applied consistently across all the accounts. And these can be reused to provision accounts with the same policy configuration repeatedly. This also eliminates any of the manual steps. Now let us see how you can apply and continuously enforce policies. Michael, over to you.
Thank you, Jyoti. Before we get started with the demonstration, we need to understand a bit about some of the VMware Aria Guardrails policy concepts. We're going to start off with templates. Templates, as the name suggests, they're a blueprint. They're a template for what we want to accomplish. These templates are written in a code that's structured as YAML, also with elements of Ginger in there so that we can make these templates dynamic. We can replace certain parts of the templates with variables or parameters. We can implement loops or other elemental programmatic structures around them. These templates enable us to do things like create objects or configure objects, or maybe even apply configurations from one object to another and link them together. Templates are stored in text files. They're human readable. And there's an example here on the right. that creates an AWS IAM password policy. So this password policy requires a certain number of parameters to be set within the policy. And by making these parameters dynamic or prompted for, when we use the template, we can make this template reusable, endlessly reusable against any AWS account. And we can configure it with whichever options we require. Moving on to desired states. A desired state is something where we take that template that we've just described and we add to it some parameter values. So where we had those handlebar notations, we take those, we substitute in some parameters. So by combining a template with some parameters and then applying it to a cloud account, we have ourselves a desired state. Configuration drift. This is what happens when our desired state, which is our template and our parameters, doesn't match the current state of the cloud account. So if we have a configuration like that AWS IAM password policy I had earlier, if we had that and we had a desired state that set certain values, certain settings on a certain account, and yet when we kind of describe the configuration on that account, it doesn't match our desired state, that is configuration drift. So if we take our desired state, as I mentioned, the combination of template and parameters as applied to the cloud account, and we compare it with the current state. So how does continuous enforcement work in VMware Aria Guardrails? We have our cloud accounts, and guardrails can look for configuration drift based on one of several triggers. Now, these triggers might be manual. So, for example, when a desired state is created in the first place, or possibly when the execution of a desired state is requested. It can also occur on a schedule. So on a periodic schedule, these desired states are evaluated. Finally, it can occur based on an event or an update to the cloud account. As part of onboarding the cloud account, we set up an event stream, and this event stream notifies us when changes occur to configured objects. And if these configured objects happen to be managed by VMware Aria Guardrails as part of a desired state, we can execute the associated desired states and make sure that this update does not introduce configuration drift or a violation of our policy. This works by describing the current state of the cloud account. So we describe it and extract current state. We're then able to compare that state with our desired state. So as I showed in the previous section, we can compare the current state with our defined desired state. And if we don't find any issues, we don't find any violations or configuration drift, we stop there, basically. And then the next time there is a trigger, either we hit a certain schedule, or there's an event, or someone requests that desired state be executed, then we go through this process again. Now, if we do find that there is a configuration drift, so we find that there's a difference between the current state and the desired state, what we do is we reinforce or enforce the desired state back onto the cloud account. So the change is automatically remediated by Aria Guardrails. Now let's look at a demonstration of the policy enforcement capabilities in VMware Aria Guardrails. This is the governance summary dashboard for VMware Aria Guardrails. It shows a number of widgets containing metrics about the number of findings, accounts, templates, configurations, things like that. In the top right, we have a widget for key actions, and we're going to start the demonstration here by looking at how we can provision new accounts. New accounts can be provisioned at the moment for AWS and Microsoft Azure. We're going to go through the process to set up a new AWS account. Our first step is to select the root account to which this child account will belong. So I'm going to select that one there. And we can also choose now where in the organization, in the AWS organization, we want to place this new account. So we can see a list of the different organizational units that are available in this root account. We're going to pick one here, and then we can go on to specify some information about the account. Now, the first thing it's going to ask us for is a name for the account. So we're just going to set demo account here for now. And then it's going to ask us for an email address. And this is an email address that's associated with the root of the new account we're creating. And it has to be completely unique across all of AWS. So at the moment, I'm just going to stick in a dummy value, but you would inevitably stick your email address in here. The role is something that will be created as part of the provision process and will enable us to get access into this account. We can optionally set a project to associate this account with, and also we can add some tags to the account. Now, I'm not going to show the creation process because it takes a number of minutes, and you don't actually see a lot going on within the actual UI itself. Once the account has been created in AWS, it's automatically onboarded into Aria Hub, and that makes it visible for us to apply policies to it, for us to look at the findings associated with that account, all automatically. Now we're going to look at how you can apply policies to cloud accounts. So we're going to head over to the policies menu item here. Here we can see a summary of the policies that we have. So we have a number of curated templates as well as a number in the library. The library is a collection of templates that we supply with VMware Aria Guardrails. And these templates can be reused, they can be copied, they can be modified, and you can even create and import your own. So the template we're after using, we can get from the library here. And we can find this particular one related to the IAM password policy, as you might recall from the earlier slide, the example that we had. We're going to use this, we're going to import it into our list of curated templates, and we can then use that imported template to create a new desired state. So our template has now been imported successfully, and we can go and have a look at it. And you might see some similarities between the slide we had earlier and this particular template. In the slide, I took out some of the information in there to make the slide more readable. But essentially, the section highlighted down here at the bottom is the section that actually does the work in the template. Most of the rest of the settings control the behavior or the visibility of the parameters within the actual template itself. Now, the template has a single state within it. You can have multiple states within a single template. As you add more states, you can add dependencies between them and things like that, and make them more complex. But what we're going to do now is we're going to select to apply a policy based on this particular template. So what we're offered or asked for initially is to select a type of account that we want to apply this policy to. Now we can apply the policy to one or more onboarded accounts. We can apply it to all provisioned accounts or all accounts. Now, for this demonstration, we're going to select a single account to apply the policy to. So we're going to go through and we are going to select that one for now. The region in this case is not relevant. We have to supply one as part of the API call to AWS, but because we're dealing with an IAM password policy and that's not region specific, we don't need to worry about what's selected here. Moving on, we got the template itself gets rendered here. So automatically a desired state name is populated. Now we can change this if we want to. And what we'll also see here is the rendering of the template and the various parameters that it prompts for. So a lot of these are actually sort of booleans or switches. They're either on or off. But we also have some numeric fields here. So we can, for example, control the minimum password length. So we could set that to be 32 if we wanted a really long and complicated password. As it is, I'm going to set that back to 18. Once we're happy with all of the parameters that we have within this particular policy, we can validate the inputs and they're all valid. And then we can then move on to determine how we want to apply this particular policy. We have a choice here. So we can either set it up to monitor the existing state of the cloud account, but not actually make any changes, or we can set it up to enforce the state. And if we do set up to enforce, the enforcement runs are continuous, as we saw in the slide earlier on, and we have continuous enforcement, and that means that the state of the policy will be checked repeatedly, and when events occur, to make sure that it is adhering to our desired state. Initially, we're going to set this up in monitor mode. As you can see, the desired state has been executed. We have a time stamp on our latest run, and we can go in and start to have a look at the results history. What we can see here from that execution is that we have an open finding against the one state, the only state that's defined within that template. So we can actually expand this and have a look. So we can see it relates to the IAM password policy, and we can see that the IAM password policy is apparently not strong. And here we can see the configuration drift, or the fact that we don't have a configuration actually. So on the right hand side we can see the settings that would be applied or that we have defined within our desired state, and on the left hand side we can see the settings defined within the current state of the cloud account. So basically there is no password policy, it's just using the defaults that AWS set. What we can now do, if we so desire, is we can go and we can choose, for example, that we would like to enforce this particular desired state. And we can select here from the menu that we would like to either immediately or continuously enforce this desired state. So instead of picking monitor, if we picked enforce, it's basically the same as what we'd be doing here. I have configured now this desired state to enforce that particular configuration on the account. Go back to the desired state. You can see now the run type has changed from monitor to enforce. And if we go and have a look at the results history, we can see there are no findings.
VMware Aria Guardrails enables detection of cloud misconfigurations with monitoring for over 350 cloud resource types and access to over 1,200 cloud-native rules. It also provides access to more than 20 compliance frameworks and industry standards. With a click-through query builder, you can search cloud resources and understand the blast radius by analyzing the cloud objects that are connected to a misconfigured resource. You can then save this query as a rule and hence create custom policies that capture the cloud asset relationships. The unique capability of detecting risks that occur due to relationships across cloud and Kubernetes services makes it possible to find misconfigurations that others overlook. It also makes it possible to bring data from all of your compliance tools and consolidate the visibility into a single place. For example, if you're using Amazon GuardDuty or Microsoft Defender for Cloud, you can not only view the violations detected in these tools within Aria Guardrails, but you're also able to correlate the misconfigurations with your threat and vulnerability data.
Thank you, Jyoti. Let's go and have a look at Cloud Security Posture Management then. Back here on the Aria Guardrails Governance Summary dashboard, we're going to go over to our Policies page again. Here we can see another widget, the Security Posture Policies widget, that shows we have a total of 1,178 policies available within here. We're having a look at these briefly, and we can see these postures are actually broken down between the different supported cloud account types: AWS, Azure, GCP, Kubernetes. Now we're going to focus for this demonstration on one that was included in the last slide you saw, and that is EC2 instance should not have. That should be enough for us to find it. Here we go. EC2 instance should not have a public IP address. Now, looking at this particular policy here, we can see the policy is active, has a high severity, it's a violation, relates to EC2, and it's present in 15 frameworks, and there are 134 findings against it. So if we have a look here, actually lists the different frameworks that include that particular policy. And we can go in here and see a little bit more information about the policy in question. So every policy has a separate ID. You also have the policy query. So if you did want to recreate this policy on your own, you can actually use this query language in Aria Hub to search for entities that match this condition. And again, lists the different frameworks that this policy relates to. So for example, we could look at the US HIPAA framework here, and it even tells us which controls within that framework relate to this particular policy. Now, if we'd like to see which findings relate to that particular policy, we have to go to the findings page under the menu here. And here we get a list, a consolidated list or unified list of all the findings that have been discovered of any type against any cloud account that's available to Aria Guardrails. So you can see here we have all the different sort of categories. We have the types of finding. We also have which provider and account it relates to, and there's also an attention score here. Basically, the higher the attention score, the more important it is that it's something you might want to pay attention to. We can also see how long this finding has been present, so it gives us an idea of how exposed these cloud accounts have been to various risks. Going back to the EC2 instance should not have a public IP address, we can see several findings here relating to lots of different resources in different accounts. So we can actually go and drill down and have a look at one of these. And if we do that, we can see a bit of a description about the finding itself. We can also find a suggested action for that finding. And again, we can see more information about the finding itself and what it relates to. And via these links, we could even go and have a look at the resource in question, and via the I suppose the relationships that Aria Hub has discovered, we can actually see which other resources in our cloud accounts are connected or related to this one particular resource. So if I was to click on that one here, It would actually go and show us our EC2 instance. It would show us as part of a VPC, a security group, EBS volume is connected to, the subnet it's on, and a potential application that it might be part of. We can also see within this view the query that would be necessary to locate this specific instance again if we wanted to use it. And we can go back and look at findings related specifically just to this resource. And this will get us back to seeing more information about this particular finding. Now, if we did want to get rid of this finding, we have a couple of options available to us. One thing we could do, if it's a legitimate configuration, is we could suppress the finding. We could tell Aria Guardrails that actually this is not something we want it to tell us about. The configuration is valid for whatever reason, it's been made, it's a valid configuration, we don't want to know about it anymore. In that case, we can suppress this particular finding. So we can choose a duration. We can either suppress it until we unsuppress it. We could suppress it for a fixed period of time, at which point the finding will come back. And we can also enter a reason in here for what we're doing and why we're doing it. The other option available to us is to remediate the issue. Now, we could do this manually, for example, by going into the AWS console and making appropriate changes to the configuration of this EC2 instance. We can also use Secure Clouds, Aria Automation for Secure Clouds, to enact the remediation. I'm not actually going to remediate this at the moment because this is obviously a fairly fundamental configuration change, and we need to be aware of what we're doing here. We're not just making a change for the sake of making a change. We need to understand the impact of it as well. But those are the two options available to us.
VMware Aria Guardrails supports end-to-end governance through 4 key use cases. In addition to policy management for accounts and security posture management, it also helps to manage excess and unnecessary permissions with end-to-end visibility into relationships between users, entitlements, and resources. And with host configuration management and security functionality, this also includes automated configuration management, compliance, and vulnerability scanning for hosts. So with this service, you can automate policy configuration and enforcement, understand the risks by viewing policy violations with relationship-based inventory context, get in-depth coverage of compliance standards for clouds and hosts, and extend policy enforcement by integrating with your existing tools. And now you can also get hands-on experience with the product by signing up for VMware Aria Hub free tier. Just add your cloud accounts and get started on your cloud governance journey today. Our team will also be available at VMware Explore that's coming up in August. It's VMware's flagship customer event for all things multi-cloud, and our team will also be available at this event to talk about popular technologies and new innovations. So please register and drop by our booth to check out VMware Aria Guardrails and come with all of your questions on cloud governance. Thank you.